let's talk about public goods. So first of all, what is a public good? Well, the definition of a public good is it's a good which is non-rival, is a new word for us, and non-excludable. What does non-rival mean? Well, that means that my consumption does not affect your ability to consume. So just, to get clarity about this, let's think about an apple for a second. If I bite an apple, you cannot bite or eat that same apple. Right? So it is rival. Whereas things that are non-rival, it means if I were to consume it, it doesn't really affect whether you can consume it. Or to say it another way, the marginal cost is zero. That's what non-rival means. Now, rivalness is important in as a characteristic of a good because it affects whether the optimal price should be positive. Okay, if the marginal cost of something is zero and we have a positive price for it, well then we know there's going to be deadweight loss. Anyways, the first of these two characteristics of a public good is that it's non-rival. The second of the two characteristics is that it's non-excludable. And that means that we can't prevent people from getting access. Now, the reason that's relevant is that if we can't charge for it, then we can't really provide it through markets. So just think about goods generally. How do we charge for stuff? Well, we put it in stores, and there are guards near the door, and people are by and large law-abiding, and so we can charge. We can exclude access if people don't pay. But imagine if it were possible to take things without paying. Then it would make it very hard to generate revenue trying to sell it. And so that in turn would affect whether a market can successfully provide it. The last point to make about this non-excludability is that if people can't be excluded, and if people are indeed as selfish as we fear they might be, then we fear that they might, quote, free ride. They might go ahead and make use of it without paying, the way a sponge would tend to do. We often take a very cynical view of humanity in this course. We really, as humans, we don't think people are that selfish. But, to the extent that there would be free rider problems, it would once again be very hard to charge money for access to something that people could have just taken. Anyway, summing up, if a good is both non-rival and non-excludable, then it is what we call a public good. Now, it turns out that goods really have this whole taxonomy. We have this 2x2 box. Now, just like the person who'd never heard of poetry didn't realize he was speaking prose his whole life, well, we didn't know about public goods until today. We didn't realize that we were actually talking about private goods all semester up till now. But now we're up here. We're talking about public goods. Now, it turns out there are two other boxes in this 2x2 matrix. And so let's just talk about them for a second and then in a bit more detail as we go. The situation in which a good is non-excludable, so you can't prevent people from getting access, but it is rival, meaning that your use diminishes my use. That's called common property. And the situation in which the goods are non-rival, so your use doesn't diminish mine, and the marginal cost is zero, but it is excludable, that one can be excluded from it. We call that a marketable public good. So for the most part, we're going to talk about public goods in this video, but we'll also talk a little bit about these two off-diagonal elements. What are some examples of these various kinds of goods before we get to each specific one? Well, first of all, the private consumption goods, apples and so forth, that's just what we've been talking about all semester. Purely public goods, goods which are both non-rival and non-excludable. Well, one very standard example that people talk about is national defense. So, to the extent that national defense is preventing some enemy nation from attacking this country, whichever this country is it possible to exclude your house from that national defense? No, not really. I mean, if we're providing deterrence that prevents these enemies from coming, it's very hard to exclude your house from national defense, so it seems like it's non-excludable. Is it rival? Well, does it cost extra to basically prevent your house from being invaded? Well, depending on the technology of invasion, certainly if we're talking about just generally keeping guys from coming here and taking stuff, it doesn't cost any extra to deter your house from being taken. So we really think of national defense as being both non-rival and non-excludable. Now, another traditional example that people used to talk about is the lighthouse. So And I have a question mark after the lighthouse and after a number of these because I want to talk about how technological change over time can move some of these goods from one box to another. But first, let's just put ourselves in the traditional view of thinking about the sense in which a lighthouse is both non-rival and non-excludable. So, is it rival? Well, if you can see the light from your ship, does that diminish my capacity to see the light from my ship? No, not at all. It's not rival at all. Zero marginal cost. Is it excludable? Well, now here's where we get into a bit of a question mark. I think the traditional view was yes. I mean, it's hard to prevent people from being able to see light. But if you think a little harder about this problem, from the standpoint, could I charge people for light? Well, no, of course I can't charge them for light, but I could charge them for the dock. I could charge them to dock their ship. So, one could imagine, excluding and charging. More contemporarily, one could think that light is not light, but some other radio waves that are scrambled or something, so one could exclude. And so, there's a question mark about the excludability of lighthouses. Let's talk about radio, another traditional purely public or pure public good. So are radio signals rival? No, not at all. If I receive radio signals, it does not diminish your capacity to also receive those signals. It's a zero marginal cost service. Is it excludable? Well, traditionally radio, AM and FM radio was set up so that anybody could receive it. But of course, it is possible to scramble the signals so that you have to pay some extra amount or some amount period to get it. We call that satellite radio. And there have been scramblers on other devices over time too. So radio is non-rival, but it's not non-excludable, at least not with new technology. And so radio is kind of migrating out of that box. Let's talk about some of the off-diagonal elements. So what are examples of things that are non-excludable but rival? So one of the traditional examples was fish in the ocean. What am I thinking about here? Well, suppose you and I are both commercial fishermen or fisher people. If I catch some fish, you cannot catch those same fish. So the fish are rival. My use of those fish diminishes your ability to use those fish. Are they excludable? Well, technologically, it's rather difficult, right? It's a big ocean. It's hard to police it. So traditionally, it had been difficult to exclude, but it was rival, and that can give rise to problems. Like if you take fish out not realizing that you're, sort of killing my ability to catch fish. Why the question mark? Well, if you actually are a grocery shopper and you go to the fish counter these days, you will see fish. Quite often, those fish aren't from the ocean, even if they're, saltwater fish. They're instead from little private oceans. They're like salmon that are raised in fjords, or various holding pens off of Chile or Norway. Now, what's going on there? In what sense is that relevant to this problem? Well, those holding pens are literally excludable. No one is allowed to take the fish out of there except the owner, and they're small enough to be patrolled. And so that is a way to solve the problem with new institutions and arguably new technology. Now, what about roads? Are roads rival? Well, sure they are, in the sense that once they get congested, you being on it makes it harder for me to use it. Are they excludable? Traditionally, it was tough, but nowadays it's not so tough. So we have these lanes on 394 and 35W, and other cities and countries have many situations where roads are priced and access is excluded. That is, you can only use it if you pay under threat of penalty. So roads are one of these elements that moves from one box potentially to another. Let me step back a second, though, before talking about the elements down here, the marketable private goods, and just to talk about why are we even talking about this. Now, remember, the issue with non-rival and non-excludable pure public goods was that markets could not provide them. And so this could give rise to a reason why we would need government in order to provide them. The issue about technological change potentially changing the excludability or rivalness of products, mainly the excludability, is it may change whether we need to rely on government for the particular product. Maybe instead, once it becomes excludable, it's possible for a private entity to charge for it and make enough money to cover the costs. So that's why these question marks are interesting and fun to think about. Well, before we move on from this slide, I just want to talk about this one other box, the excludable and non-rival. And so here we have in mind things like now satellite radio and cable television. And what do I mean by that? Well, cable TV signals and satellite radio signals are zero marginal cost. They're non-rival because my receipt of those signals doesn't diminish your capacity to receive them. It doesn't cost anything extra for you to get it over and above me once we're both hooked up. Are they excludable? Well, yes, they are. I mean, you have to be hooked up. You have to either, you have to have the descrambling code, and you have to have agreed to pay to receive satellite radio, and you have to, have contracted with Comcast or some such provider in order to receive cable television. Now, of course, I know there are people who are clever and can steal, but those are against the law, and there are penalties, and so it still is feasible to generate revenue selling these services, and that's really what excludability means. So over here, although there's a problem of non-rivalness, the ability to exclude makes it possible for markets to do it. The problem of non-rivalness just gives rise to a familiar sort of problem that we've seen before, and we'll see again in a slide or so. All right, so let's talk about marketable public goods for a minute. These, again, are those situations that are non-rival but excludable. So in a diagram, think about a good. It has a downward sloping demand curve, and let's think about a good that's being provided by a firm with market power. This product, however, has zero marginal cost, so marginal cost is right along this horizontal axis. Now typically what happens is there's a monopoly, so we could have drawn in a marginal revenue curve. There's an optimal quantity, there's a price, there it is, price monopoly. The problem here is the familiar problem that with a single price monopoly we get some deadweight loss. Why is that? Well, here are these instances where somebody's willing to pay this much, marginal cost is only this much, but the transaction doesn't occur, so this vertical distance is deadweight loss, and summing it across all those folks who don't consume but would have been willing to pay more than it cost, that's deadweight loss. Now, what would we say about this? We could say, well, markets can produce these. They can generate revenue and hopefully cover the cost and bring them to market. There is this problem, though, that it's not necessarily efficiently done. Now, that said, if you look around at goods or firms that are selling goods like this, you end up with firms like or services like iTunes and Netflix and Redbox. There are lots of new business models here doing clever pricing that in some sense tries to eliminate this deadweight loss. I mean, just talk about Netflix for a second. The marginal cost of a movie through Netflix, depending on which version of the service you buy, is essentially, or I should say the marginal price, is essentially zero. So they are doing various kinds of fancy pricing that eliminates the market failure associated with this marketable public good. So walking away from this slide, I'd say, first of all, the marketable public good is the one we're least worried about because, by construction, it's marketable. So we're not super worried that we need a government ministry of sort of movie distribution because markets can do this one even if not perfectly efficiently. Common property. So now we're going to move toward things that are a bit tougher. That is tougher for markets to do on their own. So common property, what we have in mind here are literally stems from things like town commons. So here's a picture of a Massachusetts town commons. Typically in the center of town, there is an area called the common or the commons. Traditionally, every town resident had the right to graze his cattle on the commons. Now let's think about how that's related to what we're talking about. Well, commons is this place where grass is growing, and the grass is rival in the sense that if your cow eats some grass, that grass is not available for my cow. It was, however, traditionally non-excludable, both in the sense that you couldn't prevent technologically somebody else's cow from going on there, but maybe more importantly, legally, everybody had the right. Nobody could be excluded. Now, the problem that arises if things are rival, but no one can be excluded, is an overconsumption. In the context of fishing, we often think about this as overfishing. We also sometimes talk about something called the tragedy of the commons. So without some kind of coordination here, some kind of regulation of the amount of use, it's possible for overfishing to occur, for overgrazing, and so forth. Well, as I mentioned on the previous slide, The solution in the case of fishing has tended to be the production of, or I should say that kind of the development of private slices of ocean, fish farms, where only one entity has the right to fish there, and so overfishing doesn't occur, since I'd only be stealing from myself if I were to overfish in an ocean that I personally owned. So there's some good news about common property problems. Some of them can be solved through private market action. Let's finally get to the big enchilada, which is public goods. So, just reminding ourselves what the big picture is here. Public goods have these two characteristics: the non-rivalness, which gives rise to, or is the same as a zero marginal cost, so that a positive price would generate inefficiency. Secondly, they have the non-excludability, so that we can't get selfish people to pay for it. Imagine, hey, you want to buy some national defense? And of course the answer is typically no. I'll just free ride on my neighbors. And so we tend not to be able to provide this stuff through through private action, and instead we rely on government to provide these things. The questions I want to ask in the next few slides are what's the right amount in principle? So what's the right quantity of this stuff to provide in principle? And to get to that, I want to start with a comparison to private goods. So with private goods, each individual has his or her own demand curve for the good. Now let's suppose that this is a competitive market we're talking about, so price is going to end up being equal to marginal cost. And so facing the price, this price of P, individual A chooses this quantity, or QA. Individual B faces the same price, so this line here has represents the marginal cost and price that both individuals face. Individual B has a different demand curve, chooses this intersection and this quantity. Essentially, the optimal amount of the private good that gets provided is simply the sum of the amount that each individual chooses to buy. With public goods, though, there's a huge difference. With public goods, we don't have each person choosing his or her own amount. Instead, whatever quantity we as a society choose to provide, everybody consumes the same amount. Now, what I mean by that is, imagine we're thinking about national defense, and the question is like the number of nuclear warheads that our Army is going to purchase, or whatever branch of the service. And so whatever number gets purchased, that's the number that we're all collectively consuming. So consuming may be a funny word, because you might think we're sitting and eating a little bit ourselves, but no, we're just all basking under this deterrent umbrella of the same number of these units of the public good. Anyways, let's think about how this works technically. So with public goods, each person consumes the same quantity, but different persons may well have different valuations. That is, maybe you really like nuclear weapons and I just like them a little bit. The social problem we're trying to determine, or the economic problem, is, well, what's the right quantity of this public good to purchase, given that you attach a low value and I attach a high value, or whatever. Now, the solution is going to be vertical summation of demand curves. This is new. We've been doing horizontal summation in other contexts, but this is new because, given that we all are going to be consuming the same quantity, what we have to ask is, how much do we collectively value, or how much value do we collectively attach to each quantity? All right, so let's talk through an example. It's going to be laser missile systems. I don't mean for the examples to be so military in nature here, but since national defense is the traditional iconic public good example, we'll work with one like that. All right, so optimal provision of public goods. Let's imagine we have a society with two people in it, a hawk and a dove. And what this diagram is showing is, for the number of units of this public good, 1, 2, 3, 4, 5, the marginal benefit of each unit to each type. So here's the hawk. The hawk attaches a value of 50 to the first unit. Now here we're kind of going with the discrete approach, where we're going to pretend that, or we're going to take the view that it's only possible for society to have 1 or 2 or 3 or 4 or 5 units of this good, as opposed to 1.76 or whatever. Anyways, the hawk attaches a value of 50 to the first unit, 40 to the second unit, 30 to the third, 20 to the fourth, and 10 to the fifth. Okay? And those are the marginal benefits in dollar terms as far as the hawk is concerned. And then there's this other person, the dove. The dove attaches a value of 10 to the first unit. So it's not that he or she doesn't value it at all, just this individual doesn't, this dove doesn't value it as highly as the hawk. This person attaches a value of 7.5 to the second, 5 to the third, 2.5 to the fourth, and 0 to the fifth unit. Now if these are the only two individuals in society, and we're trying to figure out, well, what's it worth to society to get a first unit? What we need to do is to add what the person A, the hawk, we need to add their valuation to the valuation that person B attaches. And indeed, the first unit here, the marginal benefit of the first unit to society is the marginal benefit to person A plus the marginal benefit to person B. And that's 50 plus 10, or 60. What about the second unit? Well, now we add the 40 plus the 7.5 and end up with 47.5. How about the third unit? Now we add 30. There's the third unit here, plus the 5, and that's 35. The fourth unit is 20 plus 2.5, or 22.5. The fifth unit is 10 plus 0, or just 10. Now, again, these are the only two people in society, so that tells us the value to society of an incremental unit, these sums. And so let's go from there. Let's go from there. So what we're doing, kind of in a more conventional sort of a picture, with continuous marginal benefit curves, is we're just vertically adding them. So we're saying if there are these two people, person A and person B, and person B attaches this value to unit 1, and person A attaches some value up here, then the sum of these two, this vertical distance plus this vertical distance equals this vertical distance. So we're just vertically summing to get to the marginal benefit experienced by society. Okay? So, yeah, that's all I want to say about that. Now, before we get to, let's think for a second, where are we trying to go with this? Where you have the marginal benefit to society, we're going to need to add in marginal cost to figure out the optimal quantity for society, and we'll get there really shortly. But I just want to mention an interesting aside that this isn't, these ideas aren't just about thinking about, say, how many laser missile systems. This is frankly also relevant to a question like this. Suppose a family is deciding on what quantity of some shared good to purchase. So even should they purchase a first flat screen TV, all right, so some big flat screen TV. Really, the value of it to the family is the sum of mom's valuation and dad's valuation and Susie's valuation and Lenny's valuation. I guess this is a very traditional nuclear family. But in any event, whatever people are living in this household that would be sharing this good, we need to sum them up. Now this is, simple, particularly if they never watch at the same time, so we can just add them up. If you and I want to watch at the same time but want to watch different things all the time, then presumably we can't just add up our valuations. But anyways, just to keep it simple, let's suppose we don't. And so there is this public goods element even to goods inside the family to the extent that they can be shared. You could even ask the question, do kids in big families have more swing sets, which is kind of a shared local public good, if you will, for the backyard. Anyways, I mention this just kind of for fun as calisthenics or application of these ideas to other contexts that are a little bit more business-like. But let's get back to the story. What we're doing in this story is we're trying to figure out the optimal quantity of a public good. What we had done as of a few slides ago is we found the marginal benefit, the social marginal benefit of a good. And, it started high and got lower because there was declining marginal benefit both to the high type and the low type. We call them a hawk and a dove. Now let's add in the marginal cost. And so what is this marginal cost? Well, this is like the marginal cost of each additional laser missile system. So we're saying it's constant. We're saying here that it's constant, that society can buy any number of laser missile systems at the same marginal cost. And so what's the optimal quantity? Well, it's this intersection right here, where marginal benefit equals marginal cost, and the optimal quantity is Q star. So the optimal amount of the public good is determined by the intersection of social marginal benefit and marginal cost. And now how about a little bit of an example, since you might need to work a problem at some point in your life. So let's have two persons. Person 1 has marginal value 10 minus q. Person 2 has marginal value 5 minus a half q. Let's say the marginal cost of this public good is 9 per unit. What do we need to do? Well, first we need to vertically sum the marginal valuations to get to this MV social or MV total, either way you could think about it. And so MV1 plus MV2, well, what does vertical summation mean? Well, it means we're just going to add the 10 and the 5. So it equals 10 plus 5 minus now the sum of the, so minus the sum of the 1 multiplying this and the 1/2 multiplying this. And we end up with the marginal valuation equals 15 minus 1.5q. If you want a picture here for a second, you could think about q on this axis and mv on this axis. One of these folks, so here's 5, here's 10, here's 15, and here's 10 on the quantity axis. So person 1 has this marginal valuation curve, which is supposed to be a straight line. Person 2 has this one. Right? It has half the intercept, half the slope. It hits this axis at the same point. The sum of them then, well, let's just say what would be the marginal value of the kind of the 0th unit. It's a funny way to say it, but we just add the 5 to the 10 to get to a 15. And the straight line that connects this 15 to this point here is the MVT. Okay, so now what we want to do is add in the marginal cost and figure out, well, what's the optimal quantity? So marginal cost comes across at 9, and this intersection is going to be the Q star. So how do we do that? Well, we set or solve this equation, set MVT equal MC, that's 15 minus 1.5Q, that's what we just found was the marginal value to society, or the total across these two. Set that equal to the marginal cost of 9, and if we solve that, we have 15 minus 9 equals 1.5 times Q, so 6 over 1.5 equals 4 equals Q star. So there we have it. That's how we would work a problem of this sort. Big picture, what are we doing? Well, we're asking how much does each individual attach to another unit, and then we're saying let's keep buying units as a society until the sum of the valuations of those marginal units falls and meets the marginal cost of those units. It's a familiar kind of logic. But what's new here is that this vertical summation idea, because the public good is being enjoyed in equal numbers by everyone. Not by equal amounts, but equal numbers of the good. All right. Let's talk a little bit about some of the challenges with allocating public goods through government. So it's, we found ourselves these kinds of goods that we aren't going to be able to provide through markets. It can be the case that the optimal amount of them is not zero, as in these examples, and so, we've got to do it somehow. The way we typically do it is through government. This can still be challenging, particularly if people differ in their preferences. So what am I thinking here? What really matters for government processes like voting is whether majority rule favors the efficient thing. And what this comes down to is a question of whether the so-called median voter, the swing voter needed for a majoritarian outcome to happen, does the median voter favor the efficient policy? And what I can show you with a little example is that sometimes the efficient thing doesn't happen. And what it really depends on is what this median voter prefers. Let me show you what I mean. So let's think about some public good. Here's what I want to illustrate in this diagram, or in this table I should say, is a world with 5 people. So persons numbered 1 through 5. There are these 5 different people. And what we're seeing in the table are the marginal benefits that these 5 people attach to a first unit and a second unit of some public good. Now vertical summation here, what does that mean? It means add across people the marginal value they attach to the first unit. So person 1 attaches 10, person 2 attaches 10, person 3 attaches 5, person 4 attaches 5, person 5 attaches 5. What are the sum of these? 10 plus 10 plus 5 plus 5 plus 5, that's 35. What's the marginal cost? That's 30. Should we have a first unit, it says down here? Well, the social benefit, summing across folks, is 35. The cost is 30. Benefit exceeds cost. So yes, we should have a first unit. By the way, should we have a second unit? Well, marginal benefit to the first person is 5, to the second person is 5, to the rest of the 3 people is 0. So the social marginal benefit is 10, whereas the marginal cost is 30. So we shouldn't have a second unit, but we should have a first. Now, suppose we're going to finance this with a uniform tax of $6 per person, where this is the first unit, right? So we're thinking about this first unit, the one that we should have, because the sum of the marginal benefits exceeds the marginal cost. Well, will voting yield the efficient outcome? Well, let's pop over here and ask that question. Do we vote for it? So what I've done in this is I've reproduced the marginal benefit that each of the 5 voters attaches to the first unit in the first row. Then I'm putting in this tax. So you're going to have to pay a tax of 6 per person. Let's put the after-tax benefit over here. So this is 10 minus 6 equals 4. This, of course, is the same. Here's 5 minus 6 equals minus 1. Sorry about the handwriting. Minus 1 here as well. And now we put this up for majority vote. We ask the question, would you like to do this? Would would each of you prefer to have or to not have this first unit of the public good? And we have 2 folks who vote for it. 3 folks vote against it. Ouch. That means it doesn't happen. No. So do we vote for it? We do not. We fail to institute the efficient thing. Now, how did this happen? Well, what happened was the median person, if we ordered them from most interested to least interested, the median person, who was therefore decisive in the voting, doesn't want it to happen. In order for voting to yield the efficient thing, we need for the median voter to value the good above its cost. Now, we're all clever people. We can think of some solutions to this problem. Presumably, if we were to tailor the taxes, maybe charge these low valuation guys less, charge the high valuation guys more, then maybe we could make it happen. But stepping back and asking, what is this relevant to? This is relevant to think about public goods that, while they are public goods, are really of interest and of value only to a small fraction of people in society. It's relatively difficult to do those through government unless one bundles them together. So think about public radio. And we can debate about whether it's really a public good. We already debated about that. But even just think about the question of whether through government in the U.S., for example, whether we can decide to allocate resources to that. And since a relatively small fraction of the population uses public radio, it's often controversial. Public television is a bit of a different story because of Big Bird. But public radio is the kind of good that's preferred by a relatively small fraction. Stadium financing is a bit similar. We just had some of that discussion in Minnesota. It can be controversial. The median voter often doesn't care or would prefer not to do it, although some people would deeply like to do it. And so it can be difficult. One way political processes work this out is by bundling public goods projects together so that there's something for everyone. But you can understand why these things are inherently challenging for political processes. All right, what are our takeaways on public goods? Well, a couple of points. First of all, public goods are those goods which are non-rival and non-excludable. What does non-rival mean? It means that the marginal cost is 0, and that was once again relevant to whether a positive price would deliver some inefficiency. Secondly, what's non-excludability? Well, that just means that it's hard or impossible to charge money for them, so it's very difficult, if that's true, for markets to deliver them. Now, how do we solve the optimal allocation problem, in principle at least? Well, optimal allocation of pure public goods arises from vertical summation of demand, or marginal valuation curves, in conjunction with the marginal cost curves. Finally, we saw that voting, which is the way we typically allocate things through government, may not yield efficient allocations of public goods.